Hello, my name is Sergey Schindler. I'm one of the software architects, or solutions architect for EMC Advanced Software Division. And I'm here today to discuss with you the ViPR and the software-defined storage that it presents to a software-defined data center. As you requested, we're going to dispense with the marketing slides and dive right into a technical overview. Let's make it interactive. I'll try to answer as many of your questions as possible. I'll try to dodge the rest. I'm prepared to do not only the slides, but actually a live demonstration of the ViPR system in an isolated and environment where we can't hurt anything by changing things around, especially on the storage arrays. And of course, we'll do a little bit of whiteboarding just to keep things interesting, right? Okay. I have to apologize for my handwriting. I can't read it myself, so if you can, great. So let's go ahead and get started. The software-defined storage that the ViPR represents is following a very simple concept. Simplifying the day in the life or the regular day-to-day tasks of the storage admin. Before the ViPR was designed and conceptualized, the life of the storage admin was pretty nightmarish, if you ask me, right? So I'm sure some of you have worked in that capacity. I worked in capacity of network admin and storage admin and overall data center management and operations. So I can and still remember with pain how complex it is to address the requirements of different software projects that require different types of storage at different times for different durations, right? So the performance, capacity, level of protection of the storage required by today's application is getting more and more complex. If you throw the virtualization in the mix, that makes it nearly impossible not only to maintain in a day-to-day environment, but also track who gets what and when this fairly expensive storage can be reclaimed for other projects that's coming up. So if you think about the tasks that the storage admin has to perform in order to provide the storage to a simple, relatively simple application project. For example, providing a block volume. This task include several steps, right? The assessment phase, where the storage admin needs to know exactly where he or she has sufficient capacity with the appropriate level of performance and protection. Whether this storage is expensive and should be only used for critical projects or relatively inexpensive, it could be used for a intermediate or QA project, etc., testing, development, etc., but less critical projects. So the usage profile, the response time, the level of protection, all that needs to be considered before even the storage array gets identified for this provisioning task. As soon as that's done, they're on to determining which particular array, which devices, which physical disks and pools can be used for this particular storage request. After that, it's on to the engineering review, change control board, CMDB, and the service desk integration, right? So the service ticket needs to be open, go through the engineering review, change control, submit it to CMDB. All the information has to be recorded there before the storage even gets provisioning. Even after the storage provision, the nightmare hasn't stopped yet, right? The storage now needs to be connected to the hosts that requested or managed by the requester. So the appropriate SAM fabrics need to be identified, the path identified, the connections established, and then masked and zoned to provide access from the application host to the storage volume or the file system. And after that, again, that's on to notifying the user that the storage been provisioned, closing the change control loop, and then informing the user as to the cost of the storage, the chargeback reports, etc. All that needs to be developed as well. Even then, it's not over, right? When the project is over, the storage needs to be identified, reclaimed, and how many of you know the storage arrays or storage volumes sitting there not used by anything but some of the orphan hosts that no longer are hosting active projects. So ViPR gets through this nightmare by providing two separate functions, right? So the first function is performed by controller, and you can see that on the screens. So the controller provides the identification of the appropriate storage that matches the project requirements, provisioning the storage itself, providing all the necessary automation tasks that require storage provisioning, zoning, masking, connectivity, export to the host, etc. And then, of course, including the workflow automation that notifies the user the storage has been provisioned, hooking the provisioning and automation workflow with the service desk, CMDB, and change control systems, and of course providing reporting afterwards. So that all that is function of the controller. Again, you probably heard all you ever wanted to about the software-defined data center and software-defined storage in the last few days. The controller, the function of the controller, while it's provisioning the storage, is actually residing outside of the data plane, right? Controller sits in the control plane. Storage arrays do not need to communicate directly with the controller for anything beyond the provisioning tasks and reporting and monitoring, right? So once the service is provisioned, whether it's the block volume or file system provisioned on the storage array by the controller itself, the communication between application and the host to the storage array itself is happening outside of the controller. So that's in the data path, and then we can whiteboard it later on. So one of the more critical functions of the ViPR controller is to communicate with the arrays themselves. And as you can see here, today we support all of the EMC arrays, the vMaxes, VNXs, vPlex, recover point protection systems, and Isilon. We also support one third-party file system, that's a NetApp filer that's supported today. What's coming down the pipe is support for additional third-party storage systems, such as the HDS, as well as a commodity array that's on the roadmap.
So that's your support is through SMIS, I guess.
Not only. So maybe that's a good point to actually do a little bit of whiteboarding, right? So let's do that. Again, we're talking about the control plane. We have our physical arrays. Right, so let's say this is going to be our vMax, and that's a VNX, a file system, and let's say Isilon, and the NetApp. And we can talk about what's on the roadmap later on. Each of this system has an onboard management provided, right? So for example, for vMaxes and VNXs, there's an SMIS. Isilon has an onboard controller, and let me add a VNX file as a logistically separate, but it could be unified VNX file or block, doesn't really matter. So VNX file has a control station, right? Isilon has a interface to its element manager, the 1FS. And the NetApp has on command, right? So what ViPR controller, and let's just use that as that's going to be our, I don't think it's working. Oh, maybe it does. So this is our control plane. Right, so ViPR controller communicates with different arrays using different mechanisms. We have a native mechanism, for example, using API to communicate directly to SMIS, or we can use an XML, for example, to communicate with on command, using an API to communicate with Isilon, as well as an API to communicate with the control station on VNX. So to answer your question, we can use whatever is available, right? Similarly, if we talk about the fabrics, which again we support majority of the fiber channel fabrics, both Cisco and Brocade. For the Brocade, we also use SMIS. And it could be the same provider. Typically it's a separate SMIS provider for Brocade. And for Cisco, again, we use the API connectivity directly to the Cisco MDS.
So a general question, not particularly ViPR specific,
of course.
Sergey, but do you think that SMIS is really mature enough to give you the depth of access to the data you need to do the provisioning task? And second question, sort of partly tied up to that, do you think that it's difficult to get vendors who are effectively not your partners but are effectively your competition to give you the right level of information to allow you to do the tasks you want to do with ViPR in an efficient manner?
Okay, so whether is SMIS mature enough to provide all the level of information we need for provisioning? To the extent that we need to communicate with arrays to provision basic services such as the volumes and the masking and zoning, yes. Some of the advanced services that SMIS does not support, we can do that through the API later on, right? So today we're in our first generation of the ViPR system, right? So currently shipping version is version 1.1. The new generation will have additional support outside of SMIS using which will be used specifically for third-party array communication. So now the backside of the flip side of that coin is whether the vendors will give us enough access to communicate with their arrays. I believe that's in their best interest as well. Regardless,
certainly as customers move more towards
that's exactly where I was going
orchestration,
with it.
Whether it's you or Chef or Puppet or any
or
other
Joe Blow or storage
any other orchestration mechanism, as customers are reaching the point where they're demanding it, and in fact many of them are pushing towards RESTful interfaces as opposed to the complexity that is SMIS.
That's exactly it. So we are we'll talk about it later on, but just to set the stage, ViPR does have both the CLI and the RESTful APIs. So whatever vendors decide to provide us regarding the external support, whether it's going to be, you're familiar with the Navisec CLI or a right, or a SIM CLI, whether it's going to be a CLI type API, XML type API, or REST API, we have mechanism already built into ViPR to support that.
And that's either going further northbound as well. So
that is correct. Well, that's actually a good point. So let's talk a little bit about a. Let me see if I can. Let's talk a little bit about ViPR architecture as well. We'll go back to the data services in a moment. If you look at the ViPR overall architecture, it is very modular. What that means is that ViPR is distributed as a virtual appliance. In terms of both support and scalability, that makes it easier to deploy. Each virtual appliance has multiple virtual machines, whereas each of the VM within an appliance performs the same set of functions. By adding additional VMs to an appliance, we can scale out and scale up as necessary. So what that means is that this load balancing and reverse proxy includes additionally a user interface. So the user interface is not integral part of ViPR. It is included with it, however, it's an individual block within ViPR configuration, within ViPR architecture. And that user interface communicates back to the controller through, again, the same API. So controller can be integrated into the enterprise environment by itself, or you can integrate the user interface as a part of the virtualized storage self-service portal.
And that API is fully documented?
Correct. So you will see in the demonstration today our native user interface. Again, all the functions that native user interface provides can be can be accomplished and documented to the user API.
Okay,
So
Yes, sir.
if you have a big array like a VMAX with thousands of disks, has it to be all under control of the ViPR, or can be only a portion of that?
That's a good question. ViPR does not control the array, right? So ViPR discovers the array and discovers its disks and physical pools, right? How much of that you decide to allocate to ViPR for provisioning is a decision that administrator makes.
Okay.
So what you're really asking is whether ViPR can live with a partially allocated array, right? Yes, the answer is yes. During the demonstration, when I can show you how only partial array can be allocated to a virtual storage pool. But before we get there, I'd like to sort of introduce the concepts that ViPR using in order to establish the entire hierarchy. So,
a virtual appliance is multiple VMs. Is a VM associated with a different class of storage, or
nope,
a different?
A VM is a VM is a VM. So if you look at this, if you look at the diagram, each of these little verticals is a virtual machine. Any single virtual machine contains all the functions, and they're scaled out by adding additional VMs. So each VM has a database, each VM has a load balancer and a reverse proxy, each VM has an orchestration engine.
Okay, your terminology is a bit confusing.
Of course. So, I mean, seriously,
It's so rare people capitulate that quickly.
I'm agreeing with you. I'm not capitulating, right? So that's why I want to get
With
to.
Howard, it is the same thing.
Yeah. Fair enough. What I want to get to is where we define the terminology, so it becomes less confusing, right?
Well, I mean, it would seem less confusing to say that a VM is a virtual appliance and you have a virtual appliance cluster.
Sure. If you want to see it that way, yes. I'm using the typical VMware definitions where there's a VApp, a virtual appliance, and underneath of that there's a several virtual
and
machines.
all the VMs share the same database and all that?
Yes.
Don't they have
VMware only
databases
then?
on each one?
Yeah, that's not what
So ViPR, as a virtual appliance, yes, it resides on the VMware cluster, correct. So as a VApp, as a distributed out-of-the-box VApp, ViPR supported on the VMware. However, it integrates in terms of the supporting the provisioning on VMware, Hyper-V, or OpenStack clusters.
So you
We have to
need
live
to
on
have
the
you need
VMware.
to have a VMware to provide storage to Hyper-V cluster. And an
Correct. Correct. So it is distributed as a OVA or OVF, depending on your preferences, right? But supported platforms are VMware.
And why do you have to maintain many VMs? It's a problem of scalability of the single VM.
Exactly. So at this point, we are able to support hundreds of arrays with thousands and many thousands of drive or the storage pools and disks and physical disks, with literally hundreds of projects, hundreds of virtual arrays and virtual storage pools.
So I'm sorry.
Of course.
So the scale is pretty interesting. Can you talk about kind of the target market for ViPR in general? So I'm thinking generally this leads to a software-defined data center environment, but what if I have a single ICE line, am I front-ending that with a ViPR, or what's the target market for?
So large enterprises, of course, where the storage admins are really head down in provisioning the storage on not only daily but an hourly basis for different projects with a multiple arrays. When we say multiple, we're talking about hundreds of arrays, right, and tens of thousands of actual physical disks and storage pools. So let's talk a little bit about the concepts, right? So we make sure that we not misunderstood. The two key concepts are the virtual storage pool and virtual storage array. Let's start from the bottom. Virtual storage pool is an aggregation of a multiple different physical storage pools discovered by ViPR while discovering the appropriate arrays. Virtual storage pool is a logical container of the like storage capabilities. So, as an example, a 20 physical storage pools with the thick provisioning and the SATA drives on all the VMAXs could be associated in a single block virtual storage pool. This virtual block storage pool could be used for thick provisioning depending on what the underlying physical storage pools are. Virtual storage array is yet another level of abstraction which allows us to tie multiple physical arrays, storage systems, arrays and file systems, without actually distinguishing them from one another in terms of their capabilities. So the virtual storage array is a logical construct. It could be associated with a department, with a geographic location, with a floor in the data center, with a northwest corner of the data center. It is completely up to the storage admin to determine how to develop this logical aggregation into a virtual storage array.
I can aggregate an EMC storage to a third-party storage and make a virtual array. So
absolutely, yes, you can.
I get two different LANs. I have them together, and I
and you have a virtual storage
bigger LAN.
Yes.
No. You can't.
Not into the. You can't
span LANs.
You can't span LANs, right?
Okay.
But what you can do is you can say, in my virtual storage pool, not a virtual storage array yet, right? In my virtual storage pool, I have a set of physical pools from VMAX, and later on from maybe from HDS. So when you need a LAN, and you say, I need a LAN of X amount of X size and protection, ViPR will go out and find appropriate system for you to house this LAN on.
Okay, so
the bit that you haven't, I guess,
storage
explained on that bit is, ultimately what you're doing is you're aggregating physical storage into logical policies that say, this is what my provisioning policy is for gold, silver, bronze, and I want to classify on this array type, that is a bronze, on this array type, that is a bronze, and I'm pooling them so I can do provisioning with that. And,
That's exactly.
And then you can take stuff from different pools depending on what you want to do.
And that classification is what defines the virtual storage pool, right? Yeah. So you can have a bronze, gold, silver, platinum virtual storage pool for block. You can define that for file. You can define it for iSCSI, etc. You can define it with a level of protection. You can say, here's my virtual pool that has SRDF protection, and here's my pools that are protected by vPlex, recover point, etc. So again, you see the examples here, right? The virtual storage arrays are aggregated on a policy-based, it's policy-based decision, aggregated on either logical basis or geographical or physical basis. You can say all my arrays in that corner are single virtual array.
So Sergey, I think the term virtual storage array can be very misleading because obviously your own products and products from other vendors allow you to virtualize storage and present it out physically through the data path as a single construct.
That's correct.
And I think that's possibly where Enrico was going down the route of, to think that maybe you were actually in some way virtualizing the data path rather than just virtualizing the management side of it. And
that's a very good point.
So it can sometimes make it a bit confusing.
Right, but that's why I want to make sure that at this point we're still talking about the control plane, right? So this is the way the controller managed the arrays, right? The data path itself is outside of our discussion just yet. The data path does not go through controller at all. Once the volume is provisioned, it is exported to the host by controller. All the connectivity is created in the fiber channel fabric. At that point, controller steps back.
Okay, so you have the control of all the fabric, and you provide zoning and whatever.
Masking and connectivity. Yes, that's correct.
Okay, and you are sure that you can manage all the paths and also on the other side can have full visibility of the
So are we sure?
It's quite complex.
It is, absolutely. But that's why when we discover the fabric, right, we discover all the ports, and we also introduce yet another concept called a virtual network. Virtual storage network, vSAN, which basically is associated with one or more virtual storage array. In that vSAN, we know which port, which HBA on array, right, and HBA on the host belong to which, connected to which port on the fiber channel switch, and to vSAN that they connected to.
All right, so I want to make sure I don't get into a naming collision thing here.
Yeah.
The term vSAN just threw me off a bit, and I'm sure.
Fair enough.
on the
All right, virtual network.
ViPR.
Right, virtual network. So think about the virtual network, and it could be your regular IP, right? It could be your fiber channel fabric. It could be iSCSI over IP, not FCOE at this point.
So with the fabric,
What? No FCOE?
No, not at this point.
And I guess that means no fiber channel over token ring either.
And they're both as useful. Yes.
It's on the roadmap though, right?
FCOE is,
yeah, yeah.
I thought we were talking ring, sorry.
So with all of that provisioning, does that go up to the HBAs in the hosts, or
Yes.
So it does.
Yes.
Does that also include things like vSwitch in VMware
No.
virtual environments?
No. So when it goes up to a host at the export level. So we don't touch the host,
Okay.
right? So that makes it simple. Touching the host is a whole different ball game, right? Typically, the hosts, the VMs, and the servers are controlled by completely different groups with a different set of permissions, with a different set of responsibilities. What we do is we export the storage resource, be that a file system, or be that a the block volume, to a host. What needs to be done on the host side, right? For example, creating initiator, right? Making sure that it's all this host can now access this, mounting the volume. We don't do that.
That's not.
right?
Yes, right. But exactly, your next step up is VCO, right? Virtual Center Orchestrator, or VCAC, the Virtual Center Automation Center, has this capability, and we fully integrate it with them.
Okay.
Right? And today in the demo, we'll use the VCO to do some of that. Now, to answer your other question, because I heard two, is what do we do with the vSwitch inside the virtual center? So with VMware, we have a little tighter level of integration. We actually export, so as we create a data center on top of the, for example, file system, and we'll do it today in the demo, we export the data center and make it available to the cluster, right? And by extension, all the hosts associated with the cluster will get access to the data center, to the data store.
Okay. Yep. So
Right.
that may not be ideal in that we don't want all the hosts in that cluster to necessarily have access to the storage, but
That is true,
That
and
can
we have an
be-
option of either selecting a cluster or the host. So if you don't want to export it to a cluster, that's fine. We can export to a single host that could be part of the cluster. We just don't care.
but that's at the cluster level, so it wouldn't actually be visible to the VMs until you do something within vCenter anyway.
That's a very good point. So here's the question then, what do we do at the VM level? We offer an integration through the VASA, right, the virtual storage API provider, and as you create a VASA provider in your vCenter, all the storage capabilities defined in the ViPR, such as all its virtual storage pools, become available to any VM that uses that particular storage policy. So these storage capabilities in the ViPR become available through the VASA provider to the VM storage policy. At that point, any VM that's associated with that storage policy will be able to utilize these capabilities, or by extension, the data store that we created. Thank you. All right? So we actually talked about it already, so I'm not going to bore you with the slide that sort of that rehashes. But let's talk about the service catalog. Every provisioning operation that's available to controller is wrapped into a what we call the service. And there's about 4 dozen or so different services, maybe a little more, which could aggregate it into categories. And as we go, these categories could be associated with block storage versus file storage, VMware storage services for file or for block, right? Storage services for Windows versus Linux and Unix, et cetera, et cetera. And of course, the data protection services as needed. you can define, or you as a storage admin can define your storage pools based on application requirements. The example here shows that, for example, you can create a VDI storage pool, you can create Exchange or Oracle or SQL storage pools, and then associate them with the specific applications using the appropriate storage through the service portal. So, any questions about that? I'd like to go back for a second and talk about data services. So ViPR Data Services is a higher level abstraction that exists on top of the controller and facilitated by and I'm going to use the black marker here, by a data services node. Data services node is again part of the same distributed virtual appliance that ViPR deployed at. However, it's a separate virtual machine. So in addition to the controller, okay. So data services node is different than the controller in that it sits in the data path. It acts as a proxy, and its main function is providing object access and for example, object and HDFS access to the applications that use unstructured data. The benefit of the data services node is that it uses the same virtual storage pools created by the controller to then export them and present them as a object compatible data stores. Why is this important? Because it creates an integration between an internal private cloud and external public cloud, such as an Amazon or Amazon S3 or OpenStack Swift.
So Sergey, whose software are you OEMing there, or is it actually EMC IP?
It is actually EMC, but APIs that we developed support at this point Amazon S3 and OpenStack Swift.
So it's EMC proprietary software?
It is, yes. So
and to create an object store, you have to put it on a file pool, right?
That's correct. Today we support object on file. The roadmap is object on commodity storage and object on block. Not here today. Today it's object and HDFS on file.
Okay.
It goes at a central level in competition with Atmos, or not?
Very good point. And at our overall roadmap strategy is to converge them together.
Okay.
Right. Today the Atmos uses proprietary hardware. Right. Atmos uses today Gen 4 proprietary hardware.
But you provide also a VSA for Atmos.
That is true. And the goal is to eventually make it all available on the commodity hardware, on the commodity storage. So Atmos and ViPR Data Services eventually will converge. Today, what we can do is use your currently stored on Atmos object data and either migrate them onto the ViPR object on file or vice versa. So if the Atmos is designed for some of the larger public cloud providers, ViPR Data Services today could be used in enterprise hybrid cloud, and you can actually move the data from Atmos to ViPR Data Services seamlessly. The additional point is that using ViPR Data Services, you can expose the data stored on object data store on top of file directly to the application. For example, if you have a big data analytics application using Hadoop as a underlying infrastructure, MapReduce or Hive can use data directly stored on a ViPR Data Services.
Okay.
Process this data, export the results, etc.
So I forget what you called the data services VM, but
data services. It's called data services.
Okay, and that's a scale-out cluster?
Correct. You can actually have multiple data services nodes added to the same virtual appliance or virtual appliance.
Serving the same object store?
Serving the same object store.
Okay. So if I'm trying to do a petabyte of medical images, then I could have as many data services nodes as I need to deal with the traffic level.
That's correct. So once the data node is configured, it gets a single IP address, and that becomes a proxy and a virtual load balancer.
Okay.
So all the data with a petabyte of medical images is going to be sent to this IP address or retrieved from that IP address,
And that's
regardless how many of them are behind it.
so it's a virtual IP address across.
That's correct.
Okay.
Right. And as I mentioned earlier,
Excuse me. So from a designing perspective, you the data service virtual appliance should be in the data path.
yes, they are in the
The
data path.
controller should be in the data path too.
No, the controller's out of band.
Controller does not have to
It
be.
can be, but it is in the same cluster. So actually,
But
it's
it's
in the same.
Well, why would it be in the data path? If I'm trying to follow your trail of thought. So controller doesn't receive any of actual data packets, right?
No.
Controller controls the system.
No, I'm okay with that.
Okay.
My problem is that so you have this VMware cluster that is that sits in the storage that you are controlling with ViPR and controls ViPR itself.
It's a little circular.
Okay.
It could be. Yes.
Who are you serving with ViPR? What is your intended audience to use ViPR?
It's much simpler to think of ViPR as two products with one name. That the provisioning and the data services,
Okay.
The controller and the data services, to think of them as one thing makes life a lot more complicated.
No. Okay.
That's another way of looking at it. If you, that's why we're sort of showing that architecturally as two separate layers, right? The data services node does talk to the controller when it needs to know where to send the data to.
But that's kind of more when it needs more space, not as every object comes in, right?
Correct.
Yeah.
Right. Once the data object store is configured by controller and that information is passed to the data services node, that is all. All it needs to know is, here's the packet coming from my application, here's the IP address of the file system I'm sending it to.
Right, so the data services node is a customer of the controller, just like any other
Yes.
data consumer would be.
Yes, absolutely.
It's kind of like if you've got UCS Director from the folks down the road, that doesn't have to be in the data path,
Right.
to borrow a Murray headline, it's just watching the game, controlling it.
Right. But the ports on the Nexus switch with that this UCS Director controls are in the data path.
Right.
Right. And that's exactly what it is, right? So, of course, here we're talking IP, so the data services node has an IP connection, and then which is exported as a URI, really. That's all there is to it. So in essence, the ViPR data services uses the same virtual storage pools to store the object data on top of, let's say, NetApp or Isilon or VNX file. In that regard, as a data path, it actually talks directly to the, I don't know what happened here, so let me grab another color. So in that regard, the data services sits in the data path and talks directly to the file system on a NetApp, Isilon, or VNX file. Whereas the controller talks to the control station, OneFS, or on command.
But the data services in the future will also provide block storage and
Yes. So object on block and object on commodity, correct?
No, but also iSCSI or other kind of stuff, like a kind of virtualization.
But iSCSI is just a protocol.
No,
right?
but you're not intending to turn ViPR data services into Invicta, right?
No.
Yeah. So no, it's it'll consume block in the future, but it won't present.
It's always
block.
object. It would always.
That's the idea.
Right?
The idea is right. The object for the big data analytics, some of the large applications. So
For data services still written in Java then? Is that?
Its interfaces in Java, right? So for example, when we provide the integration with OpenStack, does require a jar file to be made available on a Cinder instance.
You said that you can move seamlessly data from Atmos to ViPR data services, but if I use the Atmos,
I didn't hear seamlessly.
No, I know seamlessly. No.
Okay.
Okay.
Well,
Okay, you can move data, but if I use the Atmos API, how can I access data then?
you can't.
Oh, okay.
Not with Atmos API. So you have to use the S3 API or Swift.
Okay.